Purpose of this video is to illustrate the application of one-way analysis of variance using SPSS. We're going to be using the teen survey data set. This data set is provided through SPSS as part of its package. The analysis that we're going to be doing to begin with is a one-way ANOVA, looking at whether or not there are significant differences in vocabulary scores according to socioeconomic status level. The null hypothesis is that the populations for the three groups of socioeconomic status, low, middle, and high socioeconomics, share a common population vocabulary mean. That is, there is no significant difference in mean vocabulary score for the three populations of low, middle, and high socioeconomic status. The first thing that we have to do when conducting a one-way ANOVA is to make sure that there is sufficient sample sizes, sufficient cell sizes in each level of our independent variable. So we need to make sure that there are a fair number of cases in low, middle, and high socioeconomics. To do that, we go over to Analyze, click on Descriptive Statistics, and over to Frequencies, and we load in socioeconomic status. And that's really all it takes. We're just wanting to make sure that there's enough subjects in each cell that we don't have to do any collapsing in order to run the analysis. What we see in this case is we have 300 subjects and we have a minimum of 58 subjects in each one of our cells. So while our groups are not balanced, that is, we don't have an equal number of subjects in each one of our cells, we do have at least 10 subjects in each cell, so that we're confident that we can at least get a valid analysis of variance to run in this case. So we're going to go back and we're going to look at our data set again, and we are going to see to what extent our one-way ANOVA reveals whether or not there's a significant difference. To run the one-way ANOVA, you click on Analyze, you go to General Linear Model, you click over to Univariate. You send scaled vocabulary score to the dependent variable, and you send socioeconomic status to the fixed factor. These are essentially the independent variables. You can have multiple variables, but since we are running a one-way ANOVA, that means there's one independent variable, or one fixed factor in this case. We don't have any random factors and we don't have any covariates. These issues will be discussed in later videos. When we have a one-way ANOVA, there is no need for us to specify any model. There's no need to specify plots. We're not doing planned contrast in this case, but we are interested in, if we have a significant difference, determining where those significant differences occurred. So we are going to go to Post Hoc, and we're going to check, in this case, SNK, which stands for Student Newman Cools. We click on Continue. We're going to run that for this factor, and the factor in this case is SES, which is our only independent variable. So you're just going to send factor from here over to Post Hoc. We're going to click Continue. Over to Options. We want marginal means displayed for everything, which in this case is only our SES variable. We want to see descriptive statistics. We want to see estimates of effect size. We want to see what the power is. And we want a homogeneity test done to make sure that we have not violated the homogeneity of variance assumption. We click Continue, and then we click OK. The analysis comes up very promptly. It shows us that our overall mean was 52. The mean for low SES was 45.6. For medium socioeconomics, it was 51.65. And for high SES, it was 58.27. So what our question here is whether or not the differences that we are observing amongst these means is significantly greater than would be expected due to random sampling fluctuation alone. We can look at these means and see that they are different. The question is whether those differences are significantly greater than we would expect due to random sampling fluctuation alone. The first thing that we look at is whether or not we have met the homogeneity of variance assumption. This assumption is what allows us to pool the variances across these three levels of socioeconomic status. In this case, since our significance value is greater than 0.05, we do not reject the assumption of homogeneity of variance. The null hypothesis in this case is that the variances are equal. We do not reject that assumption. So we go down and we look at our between subjects effects right here. And what we see here, the main effect for socioeconomic status is listed right here. Okay, so we're just going to go across this. The mean of the sums of squares, which is the variance estimate. Okay, this is the variance estimate between groups of socioeconomic status, is 3,089.949. That is the between subjects variance. The within subjects variance is right here, 78.018. To calculate the F value for this test, we're simply going to divide 3,089.9 by 78.018, and that's going to give us the F ratio of 39.6. That is telling us that the population variance that is observed between groups is almost 40 times greater than the amount of error variance or within subjects variance that has been accounted for. This significance value here tells us that a difference of this size, an F value of this size, would have occurred due to random sampling fluctuation alone in a situation in which the null hypothesis was actually true less than one time in 1,000. We are going to reject the null hypothesis in this case because this value, whether we set our alpha at 0.05 or 0.01 or even 0.001, this significance value is less than any of those. So we reject the null hypothesis that the means for the groups within the population are different. I mean, the null hypothesis is that they are equal, so we are assuming that they are to some extent different. The partial eta squared gives us an idea of how much variance in the dependent variable of vocabulary score is accounted for by socioeconomic status. So this tells us that about 21% of the variance in scale vocabulary score is explained by socioeconomic status. The adjusted R-squared that is listed here indicates that if we want to take into account what the population estimate would be instead of the sample estimate for adjusted R-squared, we'd have to drop down from 0.211 to 0.205 because our sample was only 300 instead of 1,000. So it's still a fairly significant amount of variance that is being explained by this socioeconomic status variable. The last thing that we're going to look at is whether or not we can figure out where the significant differences occurred. The only thing that the Oneway ANOVA tells us is that there is a significant difference in these means. To understand where that significant difference lies, we're going to look at our post hoc tests. So what this tells us is that each one of these subsets, in this case, represents a significant difference. There is no overlap between this group and this group and this group. Okay? This indicates that all three of these means are significantly different from one another. So our conclusion is that there is a significant Oneway ANOVA effect. That is, we reject the null hypothesis, and we have figured out that the reason that there is a significant difference is because there's actually a significant difference between each one of the three levels. That is, low is significantly different from medium and high, medium is significantly different from low and high is significantly different from low and medium.